Hello, let's continue our Sudoku adventure with Brrrzap by Gene. So we do have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. I'm going to do German whispers first. So these green lines in the grid are German whisper lines. Basically, just any two adjacent digits in the line. These two, these two, these two, these two. They have to have a difference of at least 3. So if this was a 2, then this digit here, which is next to the 2, has to be at least 3 different from 2. So 1, 2, 3, and 4 do not work. They are too close. It has to be a 5 or a 6 in order for the difference to be at least 3. The order doesn't matter. Just take the bigger minus the smaller, and that result needs to be 3 or 4 or 5. All right. Good luck making it 6 or higher. But if you manage to, that would also be allowed. Okay. We also have these circles in the grid. These are called counting circles. If a digit is in a circle, it is in that many circles. So if, say, a 2 is in a circle, then exactly 2 circles have a 2. And if a 3 is in a circle, then exactly 3 of the circles have a 3. I don't know where I can't do it here, but anyway. So this would not, can't put a 3 there, or can't put a 3 there and there. But anyway, with the 2 there and there. Anyway, so that's just how counting circles work. If a digit does not appear in the circle, then it does not appear in the circle, which is a tautology. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I want to start with the counting circles. It's always good to think about them. Nice little property of them, if you kind of think about what it means, is first of all, we're going to count how many circles we have. We've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 circles. So the digits that appear in the circles, the unique digits that appear in the circles, sum to 8. Because if I put a digit in a circle, say a 2, it uses up 2 of the circles, leaving behind 6 circles, right? So we've subtracted 2 from our total of 8 circles. And if I put a 3 in the circles, then now the 3 appears in 3 circles, and I've used up 3 more circles, leaving 3 behind. So you can see that, but eventually when I fill all the circles up, they will sum to 8. And so how many unique digits must we have in the circles? I do think the answer is 2, naively. Based on rows, it's going to be 2. Based on columns, it's going to be 2. And based on boxes, it's going to be 2. So that does leave things pretty open. It doesn't mean we are using 2 unique digits. Now, it also means that we max at 3 unique digits, because 4 unique digits, 1, 2, 3, 4, would sum to 10 or higher. So we just cannot jam 4 digits into these circles. So it's going to be 2 or 3 unique digits, and they will sum to 8. So I don't think I can really pencil much there in that case. Like it could just be 2, 6, for example, or 3, 5. Okay. So let's think about the German whisper then. Let's start with the longest line here. So there's a couple properties of German whispers that might come in handy. First being that we always alternate between low and high digits. So a low digit is a 1, 2, 3, a high digit is 4, 5, 6. So let's say this was a low digit, 1, 2, or 3. We don't even know which low digit it is, but it means this digit must be from 4, 5, 6, because we need to add 3. We can't subtract 3 from 1, 2, or 3. So we're going to have to add 3 or more, and that's going to push us into 4, 5, 6. Notice there's no overlap. Then from 4, 5, 6, we can't add 3, so we're going to subtract 3 and get back down to 1, 2, 3. So I don't know whether we start low or high, but we must start, like, it's going to be a digit from 1 to 6 in here, so it must be a low or a high. So we're going to call that green, and then we're going to alternate green, purple, green, purple. And all we know about purple is that it's whatever green isn't. But we also know that there's 3 greens and 3 purples in every row, column, and box, because 1, 2, 3 is 3 digits, 4, 5, 6 is 3 digits. So these have to be green. Now that these are both green, these both end up purple just from the alternating every other. 3 purples here make these green. So it looks like this might be coloring exercise today. Finish the row with 2 purples. This has to be green because of the German whisper line. So all our German whispers are colored now. Do we have a way to continue this yet? So one thing that I will say is we know that we have at least 1 low and at least 1 high in the circles. And the low in the circles, I wanted to say low in the circles is at least 2, but I don't know if we, well, yeah, it is, because this is either the same digit as each other, in which case it's a 2 or a 3, if it was low. I mean, if these are low, that's 3, and so it's even worse, right? Or they're two different digits, in which case 1 and 2 would still make. So there's definitely at least a 2 for as our low. Here it would be the same thing. These two can't actually repeat, so it would be a 1-2 pair at lowest. So our low is at least a 2, and then our high. Okay, yeah, I could do it. Let's see, where can I do that? Yeah, I could do. No, maybe not. I think our high could be 4. I was gonna say our high would need to be at least 5, but so there's a special property also on German Whisperers, which is 3 and 4 are quite limited. So think about this cell here. If it was a 3, there's only one buddy for 3, which is the 6. Only one digit can go next to a 3, and so both of these would end up 6. So that can't be a 3. 4, both of these would end up 1. So 3 and 4 are special in that they cannot go in certain cells. So this can't be 3 or 4. This is from 1, 2, 5, 6. But this could be a 3 or 4. Because these could easily be the same digit as each other. But anyway, we have a 4, 5, or 6 definitely as part of our sum. But I don't know what to do about that. It doesn't limit our sum really in any interesting way. Okay. Do we have more coloring then? Because I thought I ran out of coloring. Okay, we know at least one. Not least. We know one of these is a 3 or a 4. We don't know which, but is there something in common here? So either both of these are the same digit, or both of these are the same digit as a 1 or a 6. So either these are both 1 or 6, or these are both 1 or 6. They're the same digit as each other. We don't know which, because there's going to be a 3 or 4 here, or a 3 or 4 here. 3 or 4 here would be on a circle. I don't know if it's enough. This is okay. Let's just go through the 1, 2, 5, 6s then. This is 1, 2, 5, 6 because these can't repeat. Is that it? Oh, these can't repeat. So this is 1, 2, 5, 6. This is 1, 2, 5, 6. Okay. Yeah, we can put a 6 in a circle. So we can do, well, can we? 1, 2, 3, 4. Yeah, so we do encompass, okay. So we compass 6 columns, but we only encompass 5 rows and 5 boxes. So we can't put a 6 in a circle because we can't fit also. This box is going to have a 6 that's not in a circle. So since we can't have six 6s in the circles, because one of them will be over here, we cannot put a 6 here, which isn't all that exciting. 5 would force us to use all of the rows to put a 5. Is that a problem? No, that is a problem. Okay. So this can't be a 5 either, and that makes this, that's really interesting. That makes this a low. Because if this was 5, watch what happens. First of all, I need 5 5s, and let's say that I actually managed to do it. This digit now would be high, because green is high, and it wouldn't be able to be a 5, because there's already a 5 in the column. So at lowest, it would be a 4, and then that adds to 9. I would not be able to put 4 4s in the circles, because 4 plus 5 is 9. So this can't actually be 5, making it 1, 2, making it low. So I like to use blue for low and orange for high once I know what they are, because that's just kind of what I'm used to. And now we can fix our penciling a bit. So these are actually high digits. So yeah, so that's one. I guess that's one thing I could have realized is that we have exactly one high digit on the circles, and it's not a 6; it's a 4 or a 5. 5 would mean we can't do. Well, 5 we could have. Oh, okay. So if these are 5, then this is a 1, 2 pair. That's the only way that's gonna work for the circles. But okay, so what do the lows add to? Because this is going to be 4 or 5, so the lows add to either a 3 or 4, meaning there are at most 4 low digit, at most 4 low circles. We have 3 low circles already. This being 4 or 5 makes this 1 or 2. It can't be a 3. These can't both be 1 because we can only have one circle with a 1 in it. If a 1 exists in the circle, it appears there once. So since these can't both be 1, one of them is a 2, making one of these a 5, but we know they're the same digit as each other because we can't have 2 highs in circles. So these are 5s. And that's a 6. And now that these are 5s, we only have a sum of 3 left. That means, by the way, these are all 5s. And it also means that we only have 1 2s in the circles now. One of these must be a 1, meaning this cannot be the 1, so that's a 2. Okay. And I could have devised that one of these was a 1 a little bit earlier before I devised some other things, but the order I did it is not the only order that's possible. We're just doing Sudoku now here. Got the 4 there, the 4 there. This is, I guess, this could be a 3. 2 3, 3's in one of those two. 1 2 3. Oh, this is our 4. Remember, one of these had to be surrounded by 1s or 6s. Anyway, that's a 2. That's 3 and 1. That's a 2 just because of the 5. And it couldn't be a 1. That's 1. All right, we've got our 2 3 here. So this is 2 3 6. It's not 2. That's not 2. Do I get more coloring out of this at all? Digits. All right, this is 3 5. Yeah, so this is low, this is high, this is high, this is our 3 and our 5. We got our 2 and our 3. That's a 6. This is 1 6. Yeah, so this is our low, this is our high, because this is 1 and 6. I'm just coloring first before I do the digits. I guess I don't have to do that. This is going to be 3 and 4. So, oh, this column is all blue. Perfect. That's orange. Let's see if I can finish the coloring. That'll be fun. Maybe I can't yet. All right, let's just get digits. This is 4. This is 3. This is 1. 3 in the corner, deet deet dooting. Oh yeah, sorry. This column we get orange. It's a 4. What do we get here? 1 2. We need 3 and 6. So this 6 tells us that's 3 6. All right, now we can finish the coloring. That's blue, that's orange. All right, that's a 4, that's a 2, and we're done. All right, took some thinking there, using our thinkers. But yeah, that was really interesting. There were just a few concepts that I had to sort of connect together in the right order, and then it became clear what was going on. Cool. Well, I enjoyed that. Thanks, Gene. I hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.